Hello. You found yourself in a webinar, I see. Um, let's give folks a few seconds to join, and then hopefully we can make some introductions and dive right into it. Awesome. All right, looks like we've got a few people joining, and so I will kick things off without further ado. My name is Leo Folsom. I am a solutions engineer at Datafold. I'll say a little bit more about myself on another slide. So I'll save some of that content for 60 seconds from now. But I just want to welcome you all and introduce myself. Introduce Datafold. As you can see, a data quality tool that helps you catch bad data before it burns you. Hopefully before it even exists. So that's what we're all about. We try to shift data quality all the way to the left, way upstream, way early in the review process, and enable all kinds of things to happen so that you can sleep easy and know that your code and your ETL pipelines and your migrations and your replication and everything that kind of drives your business and your product and your decision making is on data that you can trust. So yeah, thanks again for joining. Let's get into it. So start with an agenda. Intro and pleasantries. So we've already begun with some intro and some pleasantries. Please do introduce yourself in the chat. We've got a question there to get things started from my colleague Chef. So where's everyone joining from? And I'll just say I am here from Eugene, Oregon, home of the Oregon Ducks. Where we have our fair share of rain, but just had a beautiful Memorial Day weekend, clear and sunny. So that was a nice change. After that, we'll talk a little bit about data diffing, which is, I think of it as the crown jewel of Datafold. It's the technology that powers much of what we do, and why you would data diff. What is a data diff? All of these things are really critical to understanding why you would turn to Datafold to solve your data problems and not just any other tool, and why we focus so much on this in the replication, migration, and code change context. Finally, I'll walk through the tool. I'll walk through Datafold Cloud, and then we will engage in some Q and some A questions and answers. That being said, this doesn't have to happen in this order. It's just me. I do demos like this for teams all the time. I'm happy to set up something custom, and I say that because I'm going to do a demo today and a conversation much like what I would do if I were introing data to a specific team. We have, a nice sized group, but we can all get to know each other by name, hopefully by the end of it. And so please do help me customize this to my audience today. So thank you all for starting to introduce yourself, and let's go to the next slide. So of course, I've already said something about myself. I won't dwell on this, but you can see some of the places I've worked, and really excited to be joining Datafold, or to have joined Datafold now over a year and a half ago. The one thing I'll note finally, like on a personal note, is that I joined Datafold because I was a data practitioner at some of these other companies, and I found that I was really missing the ability to catch problems and do really rigorous code review before data made its way into production. I felt like I needed something more to essentially compare every value to make sure every single value was going to be valid and acceptable before I merged a code change. So I learned about Datafold. I joined Datafold. It kind of shocked me actually that this wasn't something that was just in everyone's data pipelines as I was learning how the data industry works. And so when I found a company that was solving that problem, I was very excited to join. I'm also joined by our chat champions. So we've got Elliot and Chef in the chat. And so they will have you covered if you have any questions along the way. I've also got my eye on the chat. So I see folks joining from Arizona, from Looks like there's a Canadian contingent. I'll out Elliot as being from Canada as well, so you all can discuss that in the chat perhaps. Great, so let's jump into the heart of this. A data diff is a value level comparison of two data tables. So if you walk away with nothing else, or from this presentation with nothing else, it is hopefully this image seared into your mind, one that you might fall asleep thinking of and wake up thinking of. The idea here is that you take two data sets which have a common structure. So that would most likely be because you have a data set that you have moved from one place to another, or you have two versions of it, perhaps staging and production. So in any of these situations, if you want to find the differences between the data sets, you need to diff them. You all probably are familiar with a code diff, and the result looks something like this. You have two sides, and you see the differences exactly. In a data diff, it's basically the same thing. If you imagine my fingers are the two data sets, you line them up like this, and then run a data diff. So that's actually what we do on the back. I'm just kidding. But the point is that we find the differences on a value level. We find the common primary keys. And then for this primary key, you can see in dataset A, the value is null. In dataset B, it's individual. So that exact row has a difference. Is that okay? Is it expected? Is it going to break something downstream? I'll address all of that, including how we use column level lineage to identify downstream data assets. Jing has asked about unstructured data. We don't directly diff unstructured data. We need to be able to connect to the database and query it using SQL. So if that data can be flattened or somehow stored in a relational data table, then we can diff it. So often what we do is if there's like streaming data or unstructured data that's being replicated into a SQL-based database, then that is where the diffing would occur. We do get this question with some frequency, and it is on our longer-term roadmap to include some level of diffing for unstructured data. Why should you data diff? Well, if you are a data practitioner, you might have heard some quotes like this. My dashboard is wrong. The numbers look different. Our migration is behind schedule. Maybe you have your own personal story if you're willing to share. This is a safe space. We will not share any personal anecdotes outside of this session. Hopefully, needless to say, I won't, go in. I'll move on to more of the meat heart of this. But suffice to say, in my previous roles, I heard some of this, and it was super stressful when I didn't have a good answer because I wasn't able to do a full value level comparison. I was losing detail by comparing aggregate information, by doing something simple like a row count, because I just didn't have a way of diffing at scale or automating the process. So why should you data diff? You might have a SQL code change that you're proposing. You've opened a pull request, and you want to know not only what the code difference is, but what the data difference is. Hopefully, this is going to start to seem repetitive, and then we're kind of locking in. So bear with me here, but this is a somewhat new concept sometimes, and I just want to really hammer it. The way I think of it, git diff or a code change diff, if you're like diffing to SQL files, that leaves a lot to the imagination. That relies on the developer to either look at the SQL code change and think about what it's doing. It could be a complex case statement or a misleading or confusing join, or they have to go and build the staging data themselves and then write their own SQL query to compare the two versions to find out what the real impact of the code change would be if merged. Migrating from legacy to new databases. So organizations at any size may be engaged in a large-scale migration from SQL Server to Snowflake, or from Redshift to Databricks. in order to get sign off on that migration, you need to be able to convince people that they can trust the new data. Well, the best way to do that is to show them that it matches the old data. Validating ETL or replication pipelines. Most internet-based or let's say web application-based companies, hopefully that's a broad enough term that I'm using, are going to be replicating from a transactional database like Postgres. So that's what actually is running the application when someone buys a purchase, and it's like very up to date. It stores the information in real time, and then that data is replicated on a regular basis, maybe using Fivetran to something like Snowflake, or maybe even SQL Server. But the point is some database that's used for analytics. So you want to make sure that when you're querying that analytical database, the data actually matches what's in Postgres. So how do you do that? Really, the only way to do it at scale and efficiently is to run data diffs. If there are any other situations that come to mind for you where you would want to run a data diff, I encourage you to leave it in the chat, or maybe one of these resonates with you. I would love to learn more and help that kind of inform what I hope becomes more of a discussion. This slide is mostly a joke, so I won't dwell on it. But this is kind of how I see, when I'm talking to people about should they implement Datafold, often there's a question of like value and can we invest in another tool? And usually what it comes down to is they're talking to us because either they're spending a lot of time on testing, and that is a massive cost to the organization, or they are not spending a lot of time on testing, and they are having production data incidents as a result, or it's a combination. But those are typically the two non-Datafold options that we encounter. Okay, so I'm going to dig into each of the use cases I mentioned. So data replication. We have here a scenario where data is being moved from BigQuery to Databricks, or as I mentioned earlier, Postgres to Snowflake. So this could be because you have customers or like your own clients are relying on your data, and you need to make sure you're serving it up accurately. The example I'm going to walk through is actually a cryptocurrency company which is relying on Datafold to make sure that their customers, their clients, they all have consistent data between various BigQuery or Databricks instances. The Postgres to Snowflake example is a very common one as well. Those are possibly the two most popular choices for transactional and then cloud data warehouse databases, although I probably shouldn't comment on market size. I definitely don't know the latest there. So in any case, Snowflake and Databricks, they're big ones, and we support all of these databases on the screen. So again, why do teams replicate data? Moving from transactional to analytical databases, there are a few other use cases that I haven't mentioned yet. Validating parity, so that actually I kind of touched on that, between two databases that just need to match because you have different parts of the organization or different companies who need their data to align. If you are building ML, AI, or any data science applications or tooling, then of course that data needs to be good. Garbage in, garbage out is something we're all familiar with. And finally, if you have regional restrictions or requirements around where data is stored, then you would want that data to match between regions. And why do these replications break, right? Why aren't we just trusting that the data works? Well, generally, you might say to trust but verify if something is critical to your business. But more specifically, ETL tools are software tools just like any other, which do have outages, incidents, rows get dropped, data gets corrupted. I also want to highlight that Datafold is not here to say ETL tools or custom pipelines are, risky, so to speak, but rather there could also be an element of user error. So, these tools maybe more of the breakages aren't actually the tools not doing what they say they will do, but our own assumptions about how we should use them don't match the data, right? We might be syncing data every 15 minutes, but that causes some kind of replication or some kind of miss or some kind of latency that is unacceptable. So comparing data between systems on a regular basis using Datafold and our continuous replication validation will help show you how that replication pipeline is working and potentially highlight errors that need to be caught. I mentioned also upstream breaking changes. We are relying on data to meet certain assumptions, and if they don't, then those pipelines can break. So there's a lot of reasons why you might want to validate that your replication pipelines are doing what you want them to be doing. Most ETL tools don't have native testing. I will say also on the trust but verify front, having a diversity of tools to kind of validate these most critical pipelines could be beneficial. I understand there's a attractiveness to having like a one-stop shop tool, but it does to an extent put your eggs in one basket. I don't think the solution is to have 100 tools, but to have it's almost like some kind of a redundancy in checking that doesn't rely exclusively on one vendor. I think there's some merit to that. Assertion testing, only checking known unknowns. So this is something that I'll touch on a little bit more, but basically by comparing two versions of the data, it's really a form of regression testing. So you're saying what has changed? It's not necessarily defining changes as good versus bad, although you can set thresholds for that. But what we're avoiding, excuse me, is having a reliance on developers to state what is correct, right? Because if you have a large data set or even a relatively small one, you're not going to be able to say that all of the prices, right, or all of the transaction amounts should be exactly these values. The best we can do is say, are the amounts changing in unexpected ways? You might have an assertion test that says the transaction amounts should be greater than 0, or maybe not, but for the sake of argument, you could say transaction amounts greater than 0, phone numbers 7 or 10 digits. But if a phone number changes unexpectedly, that is not going to be caught by an assertion test because you're not going to assert that every phone number should be a specific value. That would essentially be a data diff, which is what we're doing. And finally, summary level testing. Better than nothing to get like a sum of a column, but you could easily have two values swapped. You could have kind of a misleading result where the sum of a column is similar or even the same, but the values for each specific cell are not the same. It also really doesn't tell you what percentage of the values are different. So you could have a sum, a checksum, or a sum that is very close to the same, but that could represent either one specific value that is corrupted or lost, or many. Finally, a row count is going to tell you whether the number of rows changed, but that could actually mean many of the primary keys were added or dropped. So hopefully that gives you a sense for how Datafold would address continuous replication testing. I'll show you a little bit more of that in the product once I pull up the app in a couple of moments. Yes, so Allium is one of our esteemed customers, a blockchain company. I mentioned this in passing, but basically they are diffing tables on an hourly basis. They are running thousands of diffs. They have gotten us really positive feedback, or shared positive feedback about how this is actually quite a small impact on their Snowflake warehouse. Of course, you can manage your own compute spend by warehouse sizing, and we have some other optimization recommendations. But at the end of the day, they're getting a tremendous value without a lot of overhead once they set things up. They run continuously. They get notifications if anything is not identical, which is in their case the goal for the tables to be identical, although you can also set more specific thresholds. So last slide on the replication piece. This might seem a little bare bones, but I'll hopefully in the next couple of slides, you'll see why I'm throwing this graphic in front of you. So replication essentially requires continuous or regular, I should say, regular validation forever. So maybe hourly, maybe daily, but there's no end to the need to validate your ETL pipelines. Migration validation, you might think, and I used to say or think that it was more of like you validate it and then you're done. And there is an end date to migrations, but it's a little more gray than that rather than black and white. And I'll walk through how that is. And I think this is worth just noting because as you think about potentially implementing Datafold or any strategy to validate your migration, this is just a relevant topic. By the way, I will throw a question out to the audience. If there's any migration that you're currently undergoing or have planned, it would be very interesting to know, to share with everyone here, and maybe any challenges that are on your mind or any goals that you have around that. That could help drive the conversation or just give people something to think about. Yeah, so I mentioned here a lot of what I already shared about like the rationale for diffing is going to carry over from replication, so I won't walk through all of that again, but I do want to highlight a couple of things a couple of these diagrams that distinguish migration validation from replication. And this just hopefully will get your gears turning around like how you would implement this. So you might have just a lift and shift, right? You have all your data in one database and you need to move it to the other, right? And then you get some tool to do that, and then you get Datafold to validate that that was a successful shift. What I have found more often is that there is a pipeline that is sending data into database A. And that pipeline is going to switch over and send data into database B. So it's almost the case that you have this continuous replication that is occurring, and you then probably need to have it occurring in parallel for a period of time, right? And that's where you can see where I'm going with this. Teams need to, first of all, they need both to be running so they can switch over their dashboards and their data products and their SQL queries before the old is shut off, right? You can't pause, right? You have to do all this migration while the ship is running. So that is why you might have the pipeline running simultaneously, and then that would be the point where you use Datafold to compare between A and B. Now you might also be comparing between that pipeline data, the raw data, and then what is landed in A, and then what is landed in B. So this is like not entirely complete of a diagram, but hopefully that just gives you a sense for it's usually not just lift and shift. Of course, we do want to get you as fast as possible to that end date where you can get sign off and you can decommission your legacy system. Or we have even worked with companies who explicitly plan to leave their legacy system on forever. There is some stuff that they will never migrate off it, but they need to migrate certain key things into the new system, and then that validation between legacy and new will continue because they still need, different parts of the business are using legacy and other parts are going to use new, and they all need to be working with the same data. So this stuff is never simple or as simple as we want it to be, and we try to, get to know your orchestration in great detail or your goals in great detail so that then we can make sure that we support them. Finally, this is kind of a blended situation, which again, often is what we end up supporting. So you can see here, you've got your kind of parallel pipeline, dropping data into legacy and new. And then you have transformation logic, which you might need to convert from your, whether it's SQL Server or Oracle to Snowflake or Databricks or even Redshift. And then that is going to generate, your final marts layer. Now, I have two comparison points here. This is actually from two different organizations. I kind of blended a diagram here. One org is actually replicating their legacy data to the new database. It all sits there in a separate schema, and then they compare the two. And so the comparison is in one database. Another organization wants to run a comparison between the two databases. We support all of this. It really just depends on what is the best fit for you. Okay, now monitors. This is probably most relevant to replication testing. But basically what we will do is, and I'll walk through this in the app in just a moment, we give you the ability to set thresholds and schedule on which these diffs run. So this is exactly what Allium is doing. And the idea here is you get alerts via PagerDuty, Slack, webhooks, or email if the diff results show any difference or difference above a certain threshold. And finally, probably the more the original use case for Datafold, how we got off the ground as a company was actually not this migration or replication testing, but diffing in CI. So we've been building out, just for context, we've been building out support for cross-database diffing over the last year in Datafold Cloud, and that has been really big success. We've seen a lot of traction, a lot of companies. Turns out everyone's migrating and everyone's replicating data. That being said, validating code changes as you open a pull request does remain a cornerstone of our use case, and the majority of our customers do have Datafold running in CI. What that enables them to do is open a pull request, see what the impact of the code change will be, and then have a rich printout and a rich UX to explore for themselves or for their teammates before they hit merge. So I've included this diagram just because these questions do arise, and I can preempt them a little bit. The idea with Datafold and CI is you have production data, and then you have staging data, which is built in CI, or it's built manually. So in either case, you're comparing two versions of the data, and then Datafold is diffing, and then those results are written back to the pull request and also stored in the Datafold application. So I just wanted to share, this diagram. I think it applies to most contexts, and of course, can be tailored to whether you're using Airflow or DBT or any custom script to orchestrate your ETL code change management process. So I think that is going to bring me. I don't want to spoil coming soon. I should have had a slide that said, Leo, give a live demo now. So you're just going to have to use your imagination on that one. And now I will give a live demo. All right, so how about I actually kind of work in reverse here and start with the CI or code change management piece. So you've all seen a data diff here. This should look familiar from what we were just going through. Yes, so Hyrus, I hope I'm saying your name right, or Gyrus. We currently have DBT Cloud Slim CI job. Does Datafold work with the custom PR schema that DBT Cloud creates? 1,000 times yes. That works out of the box. We have an integration with DBT Cloud, and we automatically compare production data to DBT Cloud Slim CI data in the dedicated schema. So hope that was clear. Not much to elaborate on there other than yes. And you will, Gyrus, or I might need a little help practice on pronouncing your name, but Thank you again, and Jairus, got it. Okay. Thank you again for the good question and for the coaching on your name over chat. I know that's not the easiest, so thanks for bearing with me. Datafold in CI. This is how it works, and I hope this is going to kind of match with what I just described and the question I just addressed. So let me start with the git diff, right? So I mentioned earlier on the presentation, in the presentation, we have a git diff, and that is without Datafold, what the developer has or the PR reviewer has to understand what the data difference will be. So I've always thought of Datafold as, I don't know if any of you remember the movie Minority Report, but it basically, there's like a pre-crime unit where they convict people of crimes they thought about committing but haven't yet commit. So kind of a controversial movie from like the early 2000s, and that's how I think of Datafold. We are going to show you what would happen if you did what you've proposed in the pull request, and then essentially give you really rich information on what that future would look like, so that then you can decide if that's what you actually want to go ahead with. That's instead of looking at the git diff and using your imagination or trying to do this manually. So we've got 3 DBT models modified, and right at the top here we see 2 of them are different, 1 of them is identical. If you click on details, you can see we'll start with the 2 different models. So this one's sales sync. This is a small one where you can see there's 1 added row and 1 exclusive primary key. So I'm actually going to focus on dimorgs though, because that is a little bit of a richer example. So the row count has actually stayed the same. So we don't see the row count here. That is actually displayed kind of nested under here, but it's unchanged. So we just hide that. But the columns with differing values. This should be, this is, again, I think as kind of the crown jewel of Datafold, where we show you the exact number of rows where there will be data differences if you merge the code. And so possibly this information in the pull request is all you need to know in order to just review the pull request. You might be expecting there to be no differences. There are no differences, and you say, great, looks good to me, merge. If there are differences, maybe that's expected and maybe you feel good to go, but typically what people would do if this is like a critical model where they want to do a thorough review, which of course we hope they want to do, you would then click into the Datafold app. You see all the same information we just looked at, visibility into impact on downstream tables and dashboards. I'll touch on that in a moment. And then if you click on the values tab, you can see what is probably now a familiar image that is hopefully now seared in your mind of the data difference, the impact that your code change will have on the data if you hit merge. Now, if we click on this downstream impact tab, that's where we start to pull in column level lineage. And we use this to take those 3 columns that have differences and show you how they impact downstream tables, so these specific columns, or dashboards. So you can see this subplan impacts usage and org ID in this downstream model. And then it also filters down to these dimensions or attributes in Tableau. We do also support Looker, Mode, High Touch, and soon to come would be Power BI. So if there's a BI app that I didn't mention that you use, we'd be happy to hear about that and build it in a future integration. So that shows you exactly how these downstreams are impacted. I want to highlight that a couple of things actually. One is that in addition to just showing the lineage here, if you so choose, you can configure Datafold and CI to actually diff the downstreams. So that's what you see right here, data diffs of downstream tables. And you can see the impact that a code change would have not only on the modified model, but the downstream. The other thing I want to highlight is that this is not going to show you or kind of clutter the UX with models that are downstream but don't contain columns with direct connection to the modified column. So I know that's a little bit of a mouthful, but hopefully that made some sense. And I'll just show you here. This is what that lineage does look like in the UX. So this can also be a pretty valuable tool for debugging, onboarding new team members, tracking critical columns that potentially contain PII to ensure that they are managed, essentially, are well governed. The dashboards that are critical are not impacted. I personally, I was actually using this just last night to do some of our internal analytics, and something wasn't looking quite like what I wanted it to. And I was able to pull the SQL query that is used to build lineage. So we use the query logs from your data warehouse to construct this graph. And that helped me kind of work my way upstream. So if I switch to upstream, you can see how dim orgs is connected to these upstream models. And so that helps me, work not only through a DAG that you might have in Airflow or DBT, but seeing at the column level and understanding if I wanted to pull in, something like last name to, or well, maybe that's not a great best example. Maybe is first user like the max value for that into dim orgs. I would have a pretty clear idea of how to do that based on these relationships that I see. Let's see. Oh, so I want to highlight something else that's pretty important, and this is actually a recent development that we're excited to be launching in the near future. It's pretty much already live, but which is what I'm showing you, but this will be launched, more publicly. So this is a completely refreshed CI run page. I know most of you aren't Datafold users, so the change might not be that significant to you, but a lot of work has gone into making this really, really relevant and interactive and useful. So we've tried to put all the information that you might need when evaluating the data diffs associated with a given CI run on this page, including the downstream impact, the diffs that are that you saw here in GitHub are all going to be grouped here. Of course, the branches, info about the user and the runtime. So from each of these, of course, you can click in and look at the details. In this case, there was a primary key that was added or removed, I guess removed in that case. And then importantly, you can also actually navigate between CI runs. So you saw I said go to the latest CI run. That was, I know I clicked on that kind of quickly, but this gives you a better idea. You can switch between CI runs that are associated with the same pull request, the same commit, but maybe a run was restarted, or maybe there was a new commit added. And so the idea here is that if you go to the data diff page, I'll click on CI just because that's the topic, you can see for each pull request, you might have multiple CI runs with different diffs included. And then those diffs can be added automatically back to the GitHub pull request so that the user can, the user or the reviewer can see all that information. Let's see. I'll take a moment just to look at this diff creation form, because that is also a useful way of walking through what you can do with a data diff. So I'm going to reopen this diff that was kind of our anchor. Feel free to ask any other questions in the chat. No worries if nothing is springing to mind. I won't, I won't torture the trying to extract questions from the audience, but I am here for that if you have anything. So I'm just going to note a couple of things here. So you can leverage time travel in a database like Snowflake or BigQuery. I think kind of an undersold feature, honestly, like something that I didn't fully appreciate when I joined or when I first learned about Datafold, is you can diff any arbitrary query. So that can be extremely useful if you want to kind of just test out some logic live, not build a table even in your warehouse. It can also be a handy way of navigating around if you need to like cast a data type to compare between databases. We do automatic casting between common and normal data types between, let's say, SQL Server and Snowflake. So you do not need to manually cast all of your data types, but that is something you have a lot of options here. You can also automatically map column names. So you can see here, you might rename created at to sub created at, as I'm sure you are aware in like any migration context, you might have column names that don't match. I've messed up I can't click next because I was fiddling with things. There we go. Of course, you select your primary key. There's options around like ignoring string casing, sampling to handle massive scale. And let's see, I want to touch on a couple of other things here. Yeah, so expected changes, Peter. I'll touch on that, and then I will just walk through the cross-database diffing monitors replication piece that I haven't had a chance to show. So let me just pull that up so I don't forget. All right. Yeah, so expected changes. The fact is, there does need to be a human in the loop. But I think actually this monitor's UX will give you a sense for how we handle some expected changes. So let me just say that first. So if you have a continuous replication pipeline and you expect, let's say you expect one column to have a lot of changes, like always, because it's an updated at or imported at column. And then you expect there to be a certain number of primary keys, a certain percentage of primary keys added or removed because there's latency. So in those cases, let me move this to the center a bit. What you can do, this is not letting me edit because it's like a live monitor, but basically you can, where are we? Yes, so you can, first of all, you can just exclude those columns. So if there's a column that has like many changes expected, and you can see I've done some of that here, you can exclude it from the diff. You can also do that automatically in the CI context. This is probably the main area where you would handle expected changes if you because this is where you are notified of diff results, right? So that's how we use monitoring and thresholds. If you are expecting a percentage of rows with differences or a number, then you can configure that there, and that's where that's what determines what you're notified of. In the CI context, if you're like making a code change and you are expecting to see columns with differing values, then that's where I mentioned like a human in the loop. You're going to look at that and say, yes, that's what I expected. So there does need to be some level of review. What we're trying to do is not remove the human reviewer, but rather automate and speed up everything that they would otherwise need to do in order to do like a rigorous code review. So I guess high level short answer is for replication and monitoring, we recommend setting up thresholds and alerts so that then the changes that are expected don't trigger them. For CI, we would recommend either excluding the columns where there are expected changes that are like not meaningful, or having some concept in the proposed code change of what the reviewer should be looking for, what the desired outcome is of the code change. Thanks. Glad that was helpful. I know that is sometimes I answer that question and people are disappointed to learn that they still have a job. But no, it is important to, at the end of the day, understand your data. We're just trying to automate the stuff that is not only hard and time consuming, but if we expect developers to do it, they might take a different approach. And part of the benefit here is standardization. So if you have like a template and a boilerplate set of results that you are reviewing, that in and of itself is a value add. Just to touch on monitors from one other angle, if you have a well, let's dig into this one actually. So you've got this recurring data diff, and of course you can see an incident. changes bubble up. Right now, keep in mind we're comparing Postgres to Snowflake, so this is that continuous replication use case. So if you were to look at any of these data diffs with thousands of changes, you'll actually see a notification at the top saying per column diff limit was reached. This is another setting that we recommend configuring so that you don't unnecessarily diff millions of rows across different databases. I emphasize we are not moving all the data across the network. I hope that was clear from earlier on. Maybe I didn't really mention that. We are not moving data across the network. We have a unique hashing algorithm which removes the need to do that, and that allows us to diff between databases performantly and efficiently, and also without introducing risk of data loss or corruption in the diffing act itself. So with that being said, typically you don't need to diff every single row to find errors like this. You can, of course, always kick off a new diff and find the full set of results that are missing, added, or corrupted in some way. But typically, we find that teams they value more the speed to reach a conclusion that the tables are not identical. So if that limit is reached, you would then see a section of results or complete results in this case. So this is actually specific numbers if we're absolutely sure of the specific number in the amount that we were allowed to diff. But basically, the idea is you have full control over any egress, any compute, so that you can get meaningful results fast and then rerun as needed. So that would set off all the Slack and PagerDuty notifications. And then the other thing I just want to note is that if you create a diff, you can then just click here to create a monitor from it. So you might run a few diffs, decide, okay, this is the one that I want to be running on a recurring basis, and then you can really easily do any final refinements. There's that egress limit, the per column diff limit, set the thresholds, and then configure your monitor. So I see Chef is wrapping me up in the chat. I am here if you want to have any more live questions. I don't have anywhere to go at this exact moment, but I also want to respect your time and thank those of you who have joined and stuck around. Let me pull up a visual so that this can be the swan song of this presentation. Is that visual I want seared in your mind of the data diff. And I will also, before I forget, show you my last slide. So coming soon, we've got pretty exciting updates to our observability and monitoring tool set. So UI improvements, state tracking, business logic checks, as well as, I mentioned this earlier, a really exciting no-code CI update, essentially allowing you to do the whole CI process by pointing and clicking, which is going to really unlock that capability for a lot of teams. We are also going to be in San Francisco the next 2 weeks for Databricks and Snowflake conferences. And here is my email. So thank you again for joining. And I'll stick around for a minute and then leave it at that. Really appreciate all of your time. All right, I think I'll end it here. So thanks everyone again. Have a good day.